everyone. Thank you for joining us today. My name's Callie and I'm going to be your host, and I hope you're having a great Wednesday so far. I wanted to say welcome to our latest webinar series, Advancing in Predictive with Alteryx. And in this hands-on session, we're going to be joining Dr. Kyle Roberts to focus on the topic of time series. So we'll be learning about data prep for predictive with time series data, how to use Alteryx Decision, AR, IMA, and ETS tools to develop models for production, how to score new data, and lastly, how to gain insight on developing the best models and test competing models. Be sure to follow along and check out some of our previous webinars covering a range of topics such as data governance, visualizing data, mitigating risk of transformation projects, modern data warehouses, and so much more, which all can be found on our website under webinar archives. And so now for a few housekeeping things before we get started is that this webinar is going to be recorded, and the recording, as well as any resources mentioned today, will be emailed to you within the next few days. And additionally, we'll have some time for a few questions at the end of this webinar, so feel free to pose any questions you may think of in the chat as we go along, and we'll cover those later. With all that being said, I'm now going to go ahead and introduce today's speaker, Dr. J. Kyle Roberts, who is Technion's client success leader and data scientist. Kyle has held several professional positions at Southern Methodist University, Baylor College of Medicine, and the University of North Texas. He co-authored the Yacht package in R programming language, and additionally, Kyle is an expert in multi-level modeling and co-authored the Handbook of Advanced Multi-Level Analysis. And with all that, Kyle, I'll pass it off to you.
All right, thank you, Callie. So we're talking about time series today, and this is one of the topics I really enjoy, and mostly because it's hard, and I like hard stuff. And so we're going to be talking a little bit about the types of things that we're doing in time series, kind of some of the new areas that we're working in, and then kind of where the industry is leading. But then I'm also going to show you how to do this stuff inside of Alteryx. So idea is we're going to go about 30 minutes, but if you do have questions, please go ahead and throw them into the chat. We'll try to get to all of those. But first, wanted to let you know, the data I'm going to be using is available. They'll be up on this website, and so you'll be able to pull that down later, as well as the recording from this. The time series data structure is important to start with, mostly because typically we have data that come in what we call wide format. And so a lot of the databases that you're going to be pinging, you're going to be working against, will store data this way. And so you'll think of a column as being a specific date. So for this example, January, February, March, you'll see kind of data appearing in your data set, or kind of those types of things, whether it's a data warehouse or you have some data sets being passed over to you. It will appear sometimes like this, and may even up at the top it may here have like a 2020 and then a 2021, 2022, all the way all the way moving forward. The problem is that when we're analyzing this type of data, any type of time series that's going across time, we actually need it to be in what's called a long data format. And so if you can see, these are the same data sets, they're just structured differently. So again, the top one's wide, the bottom one's what we call long. And you probably, if you're an Excel junkie, you probably know that you can produce this just by doing a pivot table. It's also possible to do this inside Alteryx, and I'll show you how. But this is very important because we want to think of this as really we're going to be looking at two variables, one that's going to have our score and the other one that's going to have whatever our date field is. And that's how we're going to analyze our data, is in this long format. And so still the same data, we're just doing that pivot function to it. Okay, so in talking about that, there are different flavors of time series, and that's one of the things we're going to talk about today. I'm only really going to show you two because that's the two that you can do in Alteryx. You can do the third one in Alteryx also, but it would be pretty difficult. You would have to actually spin up an instance of R to do it, or and actually use something like a LME4 or something like that. Yeah, so anyway, it's a difficult way, but let me kind of show you what these three are. The first is ARIMA. This is typically used when your future forecast depends only on your most recent observations. So these are what we call auto-regressive models, and there are multiple different structures we can do. And, we can do an AR1, we can do, we can just do an AR model. We can do certain lag times, so meaning that we're going to make a greater dependency on, let's say, 3 days back, or 7 days back, or 10 days back, or a month back, or excuse me, however we want to think about these things. And so the ARIMA really is kind of, that's the type of analysis we want to do when we're seeing, okay, this is really like how my score is today is really dependent on how the scores have been in the previous few cycles. So for example, let's talk about sales for an item. And let's suppose we have an item that has really kind of no seasonality component to it. It really just the sales on it are somewhat dependent on, how we've been doing recently on the same amount on that. So we wouldn't do that with something that's like if we're in a grocery store, something that's more summertime, something we would eat, like a watermelon. We wouldn't look at watermelon sales in an ARIMA because that's highly seasonal. But we might look at something like sales of canned green beans that tend to, that we can get an idea around. Really, that's not a seasonal item. Really, how much we're going to sell is really mostly dependent on how many we've sold recently. Okay, that's when we would want to use an ARIMA type model. The sales forecasting is really highly dependent on what your last few data points were. Okay, as opposed to the ETS model, this is typically used when there is a seasonality trend among the data. So again, watermelons would be a good example of this. They tend to sell a lot more in the summer. And in fact, there's very few of them in the winter when you're having to grow them from other places. And, me being from Texas, we watch the watermelon sales quite a bit because this is quite a few of them are produced here, especially down in South Texas. And so that might be something that we would expect. And as any self-respecting Texan would tell you, you don't eat watermelon in December because they're not good and they're grown in a non-natural state, if you will. So that would be something where we would be kind of more in an ETS type model. And then you have something called multi-level time series. This is really pushing beyond what Alteryx can do natively, but it can do it inside of R. And so this is, again, I'm not going to show how to do this. It's pretty complicated, but this is when you want to use something called random effects and model what we call time varying covariates, meaning that so there are things that change across time with your data. So for example, let's suppose you're wanting to look at the level of ice cream sales, and you have the covariate that you want to include in there that is maybe, let's say, outside temperature. That may be a kind of a good predictor of that time series out, or how many ice cream sales you're going to have, because basically outside temperature, or maybe even too, it's when it rains a lot, people don't get out, so they don't. So they don't buy ice cream sales, let's say from an ice cream vendor, not just from a grocery store, but from an ice cream vendor. And so when it's raining, people don't get out, and therefore ice cream sales drop a little bit. So that's when we would do what we call time varying covariates. Now that's only available in multi-level time series. And the other ones, you can use covariates. It's not straightforward. And again, if you do have things that you think mitigate why scores are the way they are, really, you need to be talking about the multi-level time series, not ARIMA or ETS. Okay. All right, so finally, here are two of my favorite books on time series. I love this book, Applied Longitudinal Data Analysis by Singer and Willett. I actually knew Judy back in the day, so both she and John were professors at Harvard, and so I'd spoken at a few events with Judy. She's absolutely wonderful. I really enjoyed working with her. And then for those of you that are kind of in the stats realm, you will probably recognize the name Andrew Gelman. And then also Jennifer Hill. I think Jennifer maybe even was one of his former students, but this is a book that does multi-level analysis or hierarchical linear models. The same thing, but you can do time series with this. The great thing about these is they both have really good supporting websites where you can download all the code and all the data sets. And so I just wanted to show those to you. And then finally, just a moment about Technion is that we are a consulting firm that we do quite a bit with, and in fact, many of you who might be on the webinar right now, we may have done work with in the past. But if there's anything after this that you go, hey, I'm actually interested in more help with that, or my company is looking at doing a strategic data assessment or something like that. We're trying to look at what does our blueprint going forward look like. We'd love to get in contact with you. So you can reach out to me or reach out to Dave or reach out to Callie. We'd love to chat with you. But now, having said that, let's get into some Alteryx. And so let me share a different screen now, and we'll kind of talk about what does this look like. So the first thing is that remember that before, one of the things we discussed was that what does it look like when you have this wide data? So what I did is I just created a really simple data set that has time 1, time 2, time 3, and time 4, and then these scores here. And I wanted to show how to use some of these transform tools, notably the transpose. And so do you see it? Even the picture in here even looks like it's going from a wide data set to a long data set. And so the setup on this is pretty simple, is that I take all of my data columns, and now all I'm doing is I'm just pivoting them down. So a key column might be almost like a grouping column, but we're not doing grouping this time because it's relatively straightforward. And so if I run this, you'll see that now sorry about that. The output of that is I have a variable called name that is all of those date codes. So in this case, it's just T1, T2, T3, and T4. And then there's that value for each of those are now pivoted down. And so this is almost ready for Alteryx, but this is just a simple example. If we wanted to run this as a time series, first of all, we would never do it with 4 data points. But then the second thing is that what we would want to do is actually convert these to date fields. And so that would be of a format like 2021-01-01 and then 2021-01-02. And so that would have those date fields in there. Okay. That's a really simple way to do that. But you're going, Kyle, that's great, but my data is never that simple. Okay. Let's look at something that's a little bit tougher. So I'll run this through real quick. So here's a great example of what we would typically have in a time series type of data set, and that we have some sort of variable that is, this is typical Excel file that's sent over to me to analyze, that I'm looking at the average number of returns for each month, the number of customer visits they had for that month, the number of holidays, and then the night shift manager. Okay, so all of those different things. Now, I'm going to actually pivot this a couple of different ways. So the first thing I'm going to do is I want all of this stuff in a long format. And so now in this case, because the data is like this, and this variable, I want to honor that all of this row really belongs to average returns, and all of the second row really belongs to average to customer visits. So when I pivot this down in my data columns, that's going to be my January, February, March, April, May, June, July, all the way through December, right? Okay. But this key column is a variable. And so if you see now we've honored, I've got January through December, there are my scores for average returns. And then there's my night managers across all of those months. Okay, so all of those things have been pivoted down, and now I've honored the fact that each one is in its own set. Now I might want to clean this up even a bit more, and so instead of doing a transpose or a pivot down, I want to pivot it back up. So I'm going to use the crosstab tool, which is oddly enough an unfortunate name because in statistics crosstab means something totally different. But here's what I'm going to do with this, and you can see the output of this here. Is that I still want my date field, April, well, and actually when we pivot up, it's going to put it in alphabetical order, which is a little bit of a struggle there, but that's okay. I'm basically telling Alteryx, let me pull this over so you can see a little bit better, that I want you to group this data by the variable name. And so if you remember from here, there's the name. That's how I want it grouped. Okay. So that's basically grouping by month. The column headers is going to be in variable. You remember what that was? That was this. Okay. It's a different variable. And then all of the data is going to be in that value column, which is this one. And so now this is great because I've got my average returns there for all of my months. Okay. I've got all that information in there. I've now got it sorted to where I've got a column for average returns. I've got a column for customer visits. I've got a column for holidays and a column for night manager, but then it's aggregated by all of those different months. Okay. And this is the way that I would want my data to actually then appear inside my data set. Now I could run my analysis if this were an actual date field. And if we needed to, we could actually change that. Okay. But this is just all about setting up the data so that it's ready to run. So let me disable this real quick. Okay. And let's look at this first ARIMA example. Okay. So I have a data set I'm using called ARIMA EX. And so I'll tell you what I'm going to do is just give you a preview of this data set. So I've got a field here, it's just called field one, that it's pulling in from a CSV. So it's recognizing that field one is just a kind of a marker field. I've got returns, and then I've got the dates, and then I've got the number of visits. Okay, so in essence, what we're doing is we're trying to see across time how many returns did we have, and is that going to make a difference, you know, across going forward. And it looks like we have 3 years worth of data. It looks like it's probably taken the number of returns is taken, or average returns is taken on the last day of every month. And sure enough, that does look right. But as you know, those of you that have done this type of thing before, anytime you pull in a CSV file inside of Alteryx, everything gets imported as a string. And we don't want it as a string. We need this date as a variable. We need the returns, and then the visits as actually numeric fields. So we could do a couple of ways to get the dates the way we wanted to. I typically use date time parse inside of a formula field, or we could just pull in our parsing tool and pull in our date time parse tool. Okay. The only reason I typically use the formula is because if I need to do some other things in here, I can also do it, you know, with a single tool instead of having to pull in that date time parsing tool and then also pull in a formula after. So that's just my the way I've done things. Okay. And then what is after that, we'll have these as they'll actually be as a date, as a float, and then also as a double. And so, and then that field one will still be just a string. Okay. All right. So then we'll want to set up this is the ARIMA. So if we're going into time series, you'll see that this is the ARIMA tool that we're pulling in. Okay. And by pulling this in, I'm saying I want my model name to be ARIMA1. That's just what I'm going to call it. The target field is returns. And this is where I'm telling Alteryx, I want it to be a monthly forecast, because that's what my data look like coming in. If you remember from, if you remember from here, that's what our data looks like coming in. Okay, it's monthly. So I'm telling Alteryx it's monthly. And then let's look a little bit about it with some of the other things here. Model customization. So we can use our customize these parameters. This is way beyond the scope of today, but we could do this. And so we're actually looking at our PDQ components that for looking at the autoregressive components. This is probably a 1-week course on really understanding how to do model tuning inside of that and really understanding that. But for the most part, you're good just leaving those alone. Okay. Or we can do some sort of user specified model where, again, there's our PD and Q. This is kind of more automated, but this is where we wanted to get really specific on these. And dial those things in. Again, but certainly beyond the scope of today. Okay. And then there's some other options here for the number of periods to include in the forecast plot. So I'm going to forecast forward 6 months, and then just some graphics options things. So let's run this, and then we'll see what we got, and we'll talk about, okay, how do we interpret the things coming out of this model? So let's take just a second, and so you'll recognize down in the bottom left corner, there's a little R with a circle. That means it's booting up a local instance of R in order to run this analysis. Okay. All right. So let's look at our output. So the first is just telling us that it's got an object called ARIMA1, and if we want to pull that forward, we could actually to do some scoring or something like that, we could. All right. Here's the results. This is, for those of you that are familiar with R, this is the same type of results that you would get from R by running ARIMA, an ARIMA model on this, and then there's your kind of your PDQ structure, right? Okay, and then it's running the command inside of Alteryx, inside of R called auto.arima, and it's running it on our variable returns. Okay. So if we're looking at our plots, we're trying to notice some sort of seasonality here. Okay, so these autocorrelation functions, these should be relatively random inside there, and we sort of are. We've got a little bit of a concern in here. Basically, that's 2 lags back, or 2 months back, as to how well going 2 months back does for prediction. We would like to stay with inside these blue bars, but again, we only have 36 data points, so it's not that big of a deal. But how do we interpret this then going forward? If you're looking across here, then these in-sample error messages they're kind of hard to interpret by themselves, but they're pretty easy to interpret if we're looking at different types of models. So let's suppose we were wanting to look at this ARIMA model versus an ETS model, right? We can compare these. We can compare that MAPE or the AIC or the BIC. I mean, either one would be fine. This is a chi-square. Well, sorry. If we multiply that by -2, that would be like a chi-squared value. So we could look at that across to see which models are better as we're starting to build models and compare them against each other. This is not really telling us if our model is great going forward, but it is going to give us information about which model is going to be better as we continue on and which one's going to persist the most. Okay. So the other, and here's the thing that is worth the price of admission, is I like this a lot. So this is where we're starting to do our forecasting. So it looks like the ARIMA, it did catch some sort of trends that it's seeing. So you can see like from this period to this period is pretty similar, that to this period to this period, and then from this period to this period, that's pretty similar too. And so as you can tell, as we're going forward, it's kind of modeling this first 6 months of each year, because it looks like we're at the downward trend, and then we're modeling those first 6 months going forward. And if we want to just look at that, there's another way to think of this, is this is giving us an idea of how many returns we think we're going to have based on looking at our past data. So here's a return. So we're looking at 8.48 returns. If you see up at the top where it says fitted, for the first month going out, for the second 9, and then we're going to go all the way up to, we're predicting basically 15.15 returns for 6 months out. Okay, so this is kind of how you would use this in order to be able to kind of forecast into the future. Now, how do we know that this is any good? It's as much art as it is science. And so what I'm looking for when I look at this is I'm looking for these confidence bands and how narrow they are. That's a good way of thinking about this. And so if they're narrow around this predicted dark blue line, then I know that, hey, we have quite a bit of confidence of following the same trend going forward. If the lighter blue line and these dotted lines are really wide around there, I know then, hey, I'm probably not going to put a lot of trust into my model. There's probably not good background for that or good backing for it. And so that's not a good model. Okay. But again, too, it's kind of the, most times we're hoping to do what we can with what we have. And again, those of you who have experienced being in business through COVID, that's when you throw out all the numbers. So you absolutely, and so even though we're forecasting in here, there may be other factors that are affecting the growth. This is just basically forecasting forward based on what we observed in the past. That's what ARIMA and ETS are doing, okay? So let me stop there, and then we'll look at kind of an ARIMA and ETS example together. So I'm gonna disable this one. And let's look at one more. Okay. So in this example, now we're booting up here. Okay. In this example, I'm running an ARIMA, and I tell you what, we'll call this model Kyle 1. And this data is actually daily data, and it's a pretty big data set. And so let me kind of let you see what it looks like here. So I've already got the date field in there. And then I've got sales on an item, or actually a whole bunch of different items. There's actually quite a few items in here. And so I've got sales on those items and each of the different stores. And so what I'm doing is I made an aggregate variable that lets me to store by item so that I can really forecast the sales for like a single item inside a single store. And so I want to do that going forward. And so I made sure that, yep, the format of those are right, and this date of this is right. And then what I'm doing here is I'm saying, hey, just do item 1 that's in store 1. And so that's why I filtered this out here. And then this will run the ARIMA on that, that is the sales, and it's a daily sales. And then let's see how far forward we want to predict. I'm going to actually do 14 days out. Okay, we're going to predict, so a normal 2-week cycle. Okay, and so we're going to run this. And then the other thing I wanted to do is that I wanted to show that this is actually the tool for doing some forecasting. And so this is where you can say, all right, based on this model, can you actually produce data that will show me, okay, here's predicted, I'm going to change it to 14 days into the future, which is what we did here to see it graphically, but this will actually put it back into the data set. So let me run this. Let me make sure we're good there. Oh, it's just because it doesn't have any metadata running through. Okay, we'll run this, and again, we're going to do the same thing. We're going to spin up R, and again, this is a pretty big data set, 913,000 in there, but I'm actually just pulling forward 1,826 cases because remember, it's that one item inside that one store going forward. Okay. So let's look at the output real quick. Again, this is the same as before. That's the that we saw before, giving us those kind of almost like fit indices. Okay. And then let's look at how we're doing on forecasting here. Okay, and as you can see, there's a whole lot of data in there. Okay, so we have a lot of data points. It's over 1,000 data points. Now, if I want to see just this last part, so, and you can kind of see, well, let's actually look through this because it looks like there's a good trend there. That it looks like there's some trends that maybe are pretty similar to each other. You can tell with that darker blue, but I'm going to drag from here forward so we can just see this. Okay. So what the blue line here represents is that's our fitted. So it's almost like a back testing model. That's our fitted score versus the gray dot that's the actual. So what it does is it's kind of like thinking about going backwards. And if we've had this model beforehand, how well would it have done at predicting the actual number of sales then during that time? So you can see it does okay. The part of the concern I have here is that as I'm going forward, my confidence bands there, if you see those uppers and lowers, those confidence bands, that's a pretty big margin. And so I may look at this and go, wow, this item in this store is not doing great. It's doing fine, but we just are not going to be doing great at predicting 14 days out because we've got, if you look at that up at the top. On the upper end, I'm predicting, a little more than 30 sales, and at the lower end, I'm 9. That's quite a swing, especially if the item was an expensive item. Okay. So in essence, what we're saying is we're probably not doing great at predicting this one. Okay. For this one. So, but regardless, let's suppose someone said, well, you built your model anyway, go ahead and show me what it would look like going forward. And here is the nice nice thing about this is what Alteryx has now done is it said, okay, so going forward, here's our next 14 days worth of predictions. This is the forecast. This is the high and low. Okay. So for example, the one that we just looked at was this row 13, a high predicting 95% confidence intervals of 30.6 and then low of 9.02. Okay, so that now that there's our data going forward that we can start to, if somebody said, all right, give me a prediction, then you could say, okay, well, I'm just going to take the forecast, or I'm going to take the low 80% confidence. And so I'm going to always undershoot, or maybe you want to always overshoot. So you make sure you have enough product on the shelf. And so you take the high 80 or take the high 95, right? That would be predicting the way out. But as you can tell, these numbers, not great. A lot of, there's 10 points above and there's 10 points below. So a lot of change in those across time. So again, not the greatest model. Okay. And we could do, if we wanted to, also, we could actually run in, and we're about out of time, but we could actually run in and do a ETS also on this. And the ETS setup is almost exactly the same. That we would just pull our data down into there and then say, so the sales is our target. And again, remember that was daily, all days. And then there's some model type stuff that we can do. Some things we can offer. But again, this is going to be, how to do fine tuning on models a little bit beyond what we're doing today. Okay, but then it would run the same way. And if we wanted, we could actually compare those with each other. But I'm going to stop right there because that is a lot to do. And then the good part is we did tape this. And I realize that's a little bit like drinking from a fire hose, but let me pause right there and let me just see, Callie, do we have any questions that I need to attend to before we sign off?
Yes, we do. So the first question I have for you is, what do you do if you have data coming from multiple sites? Meaning, what do you do or how do you analyze time series when you're trying to look at trends from different stores?
Okay, so that is a great question. This is a good example of this type of data that you have it coming in from multiple stores. And remember, the way I set it up is that I'm only able to look at one item in one store at a time. Okay. If you do want to compare, let's say, how does an item function across multiple stores and how do they differ with each other? You could either in this case, we have like 10 stores, so you could run different models for each of the stores and then compare them. Or you have to go back to what we talked about previously. You have to do a multi-level time series. And so you basically, in that case, you would have what we call measurement occasions nested inside an item, which are then nested inside a store. So it'd be actually a 3-level model or a 2-level time series would be the way to think about that. It's some pretty difficult stuff, but again, it's something that I've done quite a bit of work around. And so there are quite some people that know how to do these type things. It's pretty difficult. But you can do it if you want to see, hey, is there some store dependency here? Okay, good question. Any others?
Yes, there is one more. So last month you interviewed the CEO of TangentWorks, which also integrates into Alteryx. So can Jan help us with that solution as well?
Absolutely. So TangentWorks is Alteryx on steroids for time series. Like TangentWorks is absolutely phenomenal for identifying trends moving forward, doing all types of time series analytics. And then TangentWorks can also handle this problem that we've just been speaking about concerning how do you handle coming from multiple series or from multiple stores or something like that. So most certainly. And the person to get in contact with on that is Dave Haas, who's also on this call. And I think Dave, is it right? You're just D Haas, so DHAAS. SS, right?
DHAAS at
AAS. I'm
techneonusa.com.
sorry, I just said it incorrectly. My apologies.
And we'll send out a follow-up afterwards,
Okay.
Kyle, that
Yeah.
will include our email addresses for everyone to reach out and get more information.
Yeah. So TangentWorks really does leverages the power of Alteryx, but then it has some really good algorithms in order to identify not only trends inside your data, but then also doing signal mapping and then a signal anomaly. And so that's like, if you are doing anomaly detection stuff over time series, TangentWorks is the way to go. Yeah.
And then I believe this is last question, but someone's phone rang right when you were explaining why you prefer the formula for date, time, parse to the widget. So could you elaborate?
Yeah, that's a great question. So I'm all about parsimony. And so actually that wasn't it. Sorry. Which one was it? There we go. Okay. Why I do this instead of pulling in this parsing tool is because this is just old habits. And so it does the same thing, but the reason I prefer this is because lots of times when I pull in a formula tool, I've actually got more formulas that I need to run down here. I just don't want an extra icon on the screen. And so this kind of lets me do, all of my data parsing, or I mean, all of my formulas all in one, instead of having like, first I can pull in the datetime parse tool and there, oops, I didn't drop in, did it? I'll pull in the datetime parse and then I'll do the formula. I just like, there's no real advantage of the other than parsimony. It's just, it makes it for less icons on the screen. So that's the only reason.
Awesome. And I believe that is it for the questions. So just as a reminder to anyone, if any more questions come to your mind, you can reach out to me, Dave, or Kyle, or anyone on this webinar, and we'll be sending out a recording and any of the materials. And I just want to thank everyone for attending. And if you would like more information on Technion or Alteryx, again, please feel free to reach out to any of us. So thank you, and I hope you enjoy the rest of your day.